Hi, for this day, what we're going to do is just review our formulas. Now, these are all formulas that we learned back in Chapter 2, and if you have your cumulative notes, you can find them all back in the lines chapter. So, for some of you, you probably already have the formulas and you don't necessarily need them. But for others, here they are. Really, there's three big formulas we're going to use: slope, midpoint, and distance. Slope is equal to y2 minus y1 over x2 minus x1. So remember, change in y over change in x. Midpoint, you want to find the middle of the segment. So you take the x values, add them, divide by 2. Take the y values, add them, divide by 2. The distance formula is the one that's always a little bit more complicated. I think it's just because of that big square root. But the distance formula, it's the square root of x minus x squared plus y minus y squared. And remember, with the distance formula, if you really do not like the distance formula, you can always turn your line segment into a right triangle, and it's really just Pythagorean theorem. So after this, Miss Levine is going to show you a couple of examples using slope, midpoint, and distance, and that'll be your video for today.
Okay, so what I'm going to do today is do a couple problems of the formulas that Mrs. Casey just reviewed with you. What I'm going to do is the first problem of each of your sections. So I'll do the first problem from your midpoint section, first problem from your distance section, and the first problem from your slope section in your day number 5 in your quadrilaterals part 2 packet. So let's take a look at the first problem. The first problem is the midpoint. So it's the line segment AB has endpoints A, which is 2, negative 3, and B, which is negative 4, 6. What are the coordinates of the midpoint of AB? So we're going to use our midpoint formula, which is x plus x over 2, y plus y over 2. All we're doing is taking the average of our x and our y values. So we're just going to use our values that are given. So it's going to be 2 plus a negative 4 over 2 and negative 3 plus 6 over 2. So 2 plus negative 4, we're going to get negative 2 over 2. Negative 3 plus 6, we're going to get 3 over 2, or 3/2. What we have here doesn't look like any of our answers, so we're going to keep going. Negative 2/2 is the same as negative 1, and 3/2 is the same thing as 1.5. We look at our answers. Our answer is number 2. Okay, so now we're going to do the first problem from the distance section. So we have a line segment has endpoints 4, 7, and 111. What is the length of the segment? So we're going to go ahead and use our distance formula that Mrs. Casey just reviewed. It's going to be x minus x squared plus y minus y squared. So we're just going to substitute our x values. So we're going to get 4 minus 1 squared plus 7 minus 11 squared. 4 minus 1 is just going to be 3 squared. 7 minus 11, we're going to get a negative 4 squared. Which is going to turn out to be 3 squared is 9, plus negative 4 squared is 16. Which gives us the square root of 25, which is just 5. So our answer for the first problem in our distance section is 1, which is 5. Moving on to the slope. So this is the first problem in your slope section. What is the slope of the line containing the points 3, 4, and negative 6, 10? So we're going to use our slope formula, which is y2 minus y1 all over x2 minus x1, which is just the change in y over the change in x. So we're going to go ahead and substitute our y values in. So it's going to be 10 minus 4 over negative 6 minus 3. So 10 minus 4, we're going to get 6. Negative 3 minus 3 is a negative 9. We're going to go ahead and reduce that. If we reduce that, we're going to divide by 3, and we're going to end up with a negative 2/3, which is answer 3. So if you followed along in this video, you should have the first problems done in each of your sections for midpoint, distance, and slope.